Today we're going to be talking about matter and energy in chemistry. And so let's start off with a couple definitions. Matter is going to be a substance that has mass and occupies volume. It's going to take up space. Energy in chemistry is going to be the potential of a chemical substance to undergo transformation, usually through a chemical reaction so that it can transform into other chemical substances. All right, so these are two very different things, but these are the two major components of our universe. Matter can exist in three different states, and if you allow me to move my picture here for a moment, in the gaseous state, we are going to have the particles move very quickly. And they're also going to be able to move freely around the container. So there's no bonds in the gaseous state to connect these molecules or these atoms, and so these atoms can just move around wherever they need to. They're going to try and spread out as much as they can, and that's why gases have an indefinite shape, meaning they're going to take on the shape of their container, and they have an indefinite volume. Gases are also going to have the most energy of these three states. Liquids are going to be able to move, but they're not going to be able to move as quick. So the particles here are going to move kind of fast. And particles are going to be able to move by one another. They kind of slide by each other. But there will be some bonds here, and that's what keeps it apart. That's what keeps these molecules or these atoms from moving and becoming a gas and going up into the atmosphere. Liquids are going to have an indefinite volume or shape, but they have a definite volume. And they're going to have less energy than gases. In the solid state, particles are still going to move, but particles are going to move slower. And they've got these bonds connecting them and creating this crystalline structure, and so particles are going to more or less vibrate. Let's put vibrate here. So they're going to move back and forth, but because of these bonds, they're not going to break away. They're not going to slide past one another. Solids have a definite shape, and they have a definite volume. And they're going to have the least amount of energy of the three. Now, as we can have matter that goes from one state to another. So when we go from the solid state to the liquid state, that is going to be melting, and we're going to add energy to it. If we go the opposite way, we have freezing. And this is just a change in the states of matter, and they're going to be a physical change. If we go from liquid to gas, we have vaporization. If we go from gas to liquid, we have condensation. And there's a couple of others that we'll talk about later. Matter can be classified into basically two different classes. Matter can be divided into mixtures and pure substances. Mixtures are composed of more than one substance and can be physically separated into its component substances. So we can separate them without changing them, without making new substances. However, pure substances are composed of only one substance and cannot be physically separated. We have to go through a chemical reaction in order to separate pure substances. Alright, so let's talk a little bit about mixtures. Mixtures have two different types. Homogeneous, remember that from your biology days that homo means the same, and hetero means different. So we have homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures are going to be uniform, have uniform properties throughout. If we have salt water, that salt dissolves in the water, and no matter where we go in that container, the concentration of salt to water is going to be the same. Heterogeneous mixtures do not have uniform properties. So if we were to mix sand and water together, if we let it sit, eventually that sand would settle at the bottom. Our salt would never settle at the bottom. Pure substances, there's two types of pure substances. We can have compounds, which is like water, H2O, or salt, sodium chloride. All right. Compounds are going to be composed of two or more elements, and elements are going to be things like oxygen, hydrogen, all those things that we see on the periodic table. All right, so again, compounds can be chemically separated into individual elements. So water is a compound that can be separated into hydrogen and oxygen. Elements cannot be broken down further by chemical reactions. Basically, elements are the smallest full unit of chemical compounds. There are smaller pieces that make up an element that we'll talk about later, but in terms of an element, an atom is basically the smallest portion that we can have that can survive and have basic physical and chemical properties. Speaking of physical and chemical properties, a physical property is a characteristic of a pure substance that we can observe without changing its composition. This is going to include its physical appearance, its melting and boiling points, density, conductivity, and its physical state. Chemical properties describe the chemical reactions of a pure substance. Sorry if I went a little bit too quickly. Physical properties are going to be things that we have to do a chemical reaction in order to see. All right? So hence they describe this chemical reaction. Sorry, I had to find my mouse. All right, so chemical and physical changes. A physical change is going to be one in which the chemical composition of the substance is not changed. If I have water in the beginning, I'm going to have water in the end. All right, these are going to include changes of physical state, shape, of a pure substance. A chemical change, on the other hand, is going to involve a chemical reaction. So something along the lines of where we have two substances coming together to form a new chemical. Evidence of a chemical change can be the production of gas. So you're going to start to see bubbles. The release of some sort of energy, either light or heat. The formation of a precipitate, like you see here in picture C. Or a permanent color change. And I'm going to add one more for you. If we create an odor. All right, so we have 5 pieces of evidence of chemical change. All right, real quickly, law of conservation of mass, and you don't have to know this scientist's name, but Antoine Lavoisier found that mass substances before a chemical change and after a chemical change were always equal, and he called this the law of conservation of mass. All right, so the law of conservation of mass says that matter is not created nor destroyed in a physical or chemical process. Whatever we start with, we are going to end with. Similarly, energy cannot be created nor destroyed, but it can only be converted from one form to another. All right, and so this is the law of the conservation of mass. There are 6 forms of energy: heat, light, electrical, mechanical, chemical, and nuclear. All right, but the conservation of energy says that energy cannot be destroyed or created. It can only be converted. And we put these together, or Einstein put these together, and is part of what helped him create his theory of relativity, or E equals mc squared, E being energy and m being the mass. All right, and he basically said that mass and energy can be interchanged, and we came up with the law of conservation of mass and energy, which states the total mass of a system and the total energy of a system, such as the universe, is going to be constant. We are never going to change how much mass or energy is in the universe. We're only going to change how it looks, or transform the type of energy that we have. All right, that's the end of the video. We'll see you next time.